In this video, we are going to look at rational exponents and how they relate to radicals. So quick review here. An exponent, remember, is just repeated multiplication. So if I have 5 squared, that's going to be the same thing as 5 times 5. And a radical, which we write like this, a radical, this is the square root of 4, and the square root of 4, in other words, is just asking us for what number, which I'll represent with this box here, what number when we square it or multiply it by itself gives us 4. Well, you probably remember that 2 squared, or 2 times 2, is equal to 4. And that means that the square root of 4 is equal to 2, because 2 is the number that when we multiply it by itself, it gives us what's inside of this radical sign. Here's another example, the square root of 9. And so I'll write the same setup here. What number, which I'll represent with this box here, what number when we square it gives us 9? Well, 3 times itself, or 3 squared, is equal to 9, and that means that the square root of 9 is equal to 3, because when we multiply 3 by itself, we get 9. So the square root of 9 is equal to 3. Now these are all square roots because we're squaring this mystery number, but there are other kinds of roots. We can have cube roots and fourth roots and so on. And let me give you an example of a cubed root. And so we write a cubed root like this. It's the same basic structure, but we put a 3 in front here to indicate that it's the cube root. And I want to find out, what is the cube root of 8? What's the same basic idea here? We have some mystery number that when we cube it or multiply it by itself 3 times, we get 8. Well, what number when we multiply it by itself 3 times gives us 8? Well, 2 times 2 times 2 is equal to 8. So 2 cubed is equal to 8. And that means that the cube root of 8 is equal to 2. So quick review of radicals there. So let's see how this relates to rational exponents. I'm going to change my color here, go back up to the top. I think that you would agree with me if I said that 9 is equal to 3 times 3. And that 9 to the first power is equal to 9. Remember that any number to the first power is just going to be equal to that number. And 9 is also equal to 3 times 3. And I can also say that 9 to the 2 over 2 power, remember 2 over 2 is just equal to 1, and so that's going to be equal to 9 to the first power, which is going to be equal to 9, which is going to be equal to 3 times 3. Okay, now I'm going to cut out some of these numbers in the middle here and just say that 9 to the power of 2 over 2, that's equal to 3 times 3. We've just proven that. We've shown that these are all the same same expressions, the same numbers on either side of the equal sign. We just cut out the middle part here. So 9 to the 2 over 2 power is equal to 3 times 3. Now, what if I asked you what 9 to the 1 over 2 power, or 9 to the 1/2 power, what would that be equal to? Now pause for just a second and think about this. Pause the video and think about, what would 9 to the 1/2 power be if 9 to the 2/2 power is 3 times 3? Now I hope you've paused the video and thought about this for yourself for a second. If I have 9 to the 2/2 power, and that's equal to 3 times 3, and here I have 9 to the 1/2 power, then I'm only going to have 1 3 here. So 9 to the 1/2 power is equal to 3. Now you may remember over here in this teal color that we knew that we found that the square root of 9, that's also equal to 3. So if 9 to the 1/2 power is equal to 3, and then 3 is also equal to the square root of 9, then we can remove this middle 3 here and just say that 9 to the 1/2 power is equal to the square root of 9. 9 to the 1/2 power is the exact same number as the square root of 9. And both of those numbers are equal to 3. These are all the same number on either side and in the middle of this equation. That was an example with square roots. We had the square root of 9 and 9 to the 1/2 power. We can also do the same thing with cube roots. Remember, cube roots are what we saw over here. And to think about that, let's think for a moment what 8 to the 3/3 power would be equal to. Now you may remember 3 divided by 3 is just 1, so this is the same thing as 8 to the 1st power, which is the same thing as 8. And 8, we can also think of 8 as 2 times 2 times 2, or 2 cubed. And so I'm just going to, just like I did down here, or sorry, over here, where I removed the middle parts of this equation, I'm going to do the same thing here, and I'm just going to say that 8 to the 3/3 power is equal to 2 times 2 times 2. Now I want you to do this, I want you to think about, if 8 to the 3/3 power is equal to 2 times 2 times 2, what would 8 to the 1/3 power be equal to? Now, just like we did before, I encourage you to pause for just a moment and think about this. What would 8 to the 1/3 power be equal to? Well, one way that you can think about this is that with 8 to the 3/3 power, we had 3 2's multiplied by themselves, and so now we're just going to have 1 2. So 8 to the 1/3 power is just going to be equal to 2. Now over here we showed that the cube root of 8 is also equal to 2, so I'm going to write that on the other side of this equal sign. So the cube root of 8 is also equal to 2. And just to be clear here, when we have two equal signs like this, we're just saying that this number here, 8 to the 1/3 power, and 2, and the cube root of 8, those are all the same number. That's why we can put equal signs all the way across here. Now let's remove the 8 here and show that, or sorry, remove the 2 and show that 8 to the 1/3 power, that's the same thing as the cube root of 8. Is the cube root of 8. And so when we have a rational exponent, or in other words, when we have an exponent that is a fraction, we can rewrite that as a radical. Now we can just think about these in terms of variables, so replacing the numbers here just to make a general case. So if we have a, actually I want to do this in yellow, if we have a to the 1 over b power, that's the same thing, the same number as a inside of this root sign to the bth root. So just one more little example here. If we have a to the 1/2 power, that's going to be the same thing as the square root of a. I don't have to write that too, it's implied, but just to make it clear the connection there. Or if I have a to the 1/3 power, that's going to be the same thing as the cube root of a. And if I have a to the 1/4 power, that should be a 4, then that is the same thing as the 4th root of, ooh, that looks like a 9, hold on here, as the 4th root of a. And that's the relationship between radicals and rational exponents.